Welcome back to another video. So in this video we will solve O-Level Mathematics Paper 2 Variant 2 for May-June 2017. So let's start with question number 1. You're given costs for flights, accommodation and insurance which covers up to 20 days. So a family of 2 adults and 3 children travel to Sydney for a holiday lasting 14 nights. Calculate the lowest total cost of the flight, accommodation and insurance for their holiday. So the cost of flight and accommodation, they have only one option. So that will be fixed. The only two options that they have is for insurance. So we have to basically check which insurance option, this one, the on the top or the bottom one, is less. So that will be the lowest cost of the flight, accommodation and insurance combined. So let's first calculate the individual costs. So flight cost will be equal to, so 11.99 per person, and there are 5 people. So this will be 11.99 into 5. So this will be equal to 11, oops, 11.99 multiplied by 5. So this is 5,995. So this will be 5,995. And then you have the accommodation cost. Accommodation cost will be, it's 55 per adult per night. So this will be, there are 2 adults, 14 nights, and then 55 per night, plus uh, 3 children, again 14 nights and 40 per night for the child. So this will be 2 into 14, oops, 2 into 14 and then multiplied by 55, and this equals 1540. So this will be 1540 plus the other one will be 3 into 14 into 40. So this is 1680, and then you add the two and you will get 1540. So this is 3220. 3220. So then you have this insurance plan. So let's call this option 1 and this as option 2. So insurance option 1 cost will be equal to 40 per adult. So this will be 2 into 40 plus 30 per child. So there are 3 children, so 3 into 30, which is 80 plus 90, which is 170. And then insurance cost for option 2 is insurance option 2 cost is what? It's simply 155, which covers 2 adults and up to 4 children. So we are under 4 children, we have 3 and 2 adults. So this is 155. So this is the lowest option, lower option for the insurance. So lowest total cost will be, lowest total cost will equal the flight cost plus the accommodation plus the cheaper insurance option, which is 155. So this will equal, so we have 3220 plus 5995 and plus 155. So this is 9370. So $9,370. Part B is the family hires a car for 14 days and estimates their total mileage will be 750 miles. Which company charges less for this hire and by how much? So let's first calculate the cost from bonus cars. So cost from bonus cars is equals to So it's 42 per day for any mileage. So they are hiring it for 14 days. So this will be 42 times 14, which is equals to 42 into 14, $588. And then you can calculate the cost if they hire from value cars. So cost from value cars will be 20 per day. So this will be 20 into 14 because they're hiring for 14 days, and then plus zero point 0.5 per mile. So this will be plus 750 because their total mileage will be 750 into 0 0.5. So this will be uh, 20 into 14 plus 750 into zero point 0.5, which is $655. So the difference will be equals to 655 minus 588, which is 655 minus 588, $67. So which company charges less for this hire by and by how much? Bonus cars will be the answer. They charge less, and by how much? By $67. The next question is, the table below shows the population given to the nearest thousand of some countries. So part A is, in 2015, how much larger was the population of Pakistan than the population of South Korea? So you basically have to calculate the difference in population of the two countries. So the difference will be how much larger was the population of Pakistan. So population of Pakistan is larger, which is 185,133,000 minus population of South Korea. Or in fact, they're looking for 2015, so this is not correct. I will write down the population in 2015, which is 188,169,000. Minus population of South Korea is 49765,000. So let's do the subtraction. 188,169,000 minus 49765,000. Oh, I added one extra zero. Okay. So the answer is 138, 138, 138,404,000. Part B is, which country had the smallest increase in population between 2014 and 2015? So since this is only one mark, you don't actually need to calculate the difference or the increase in population for each countries. Here you can see that Pakistan's population was 185 million something, and then it changed to 188 million. So that means it increased by about 3 million. So you're changing in millions here. For China, this is 1,393,000,000. So it changed to 1,402,000,000. So this also increased in millions here. For South Korea, if you look at, it's 49 million and 49 million. So that means the change is in thousands. And for Thailand as well, you see that this is 67 million and this is also 67 million. So that means the change is in thousands as well. So we only need to calculate the difference in population for these two countries between 2014 and 2015. So we can see which had the smallest increase. So let's add another column here, increase in population. So for South Korea, the increase was how much? It was 2015, it's 49,765,000 minus 49,512,000. So the increase is 253,000. So this increase in population is 253,000. And what about Thailand? So let's calculate that as well. 67,438,000 minus 67,512,000. 223,000. So this changes 215,000. So the country which had the smallest increase in population between 2014 and 2015 is Thailand. Write the population of South Korea in 2014 in standard form. So 2014, the population is this 49,512,000. So in standard form, I'll need the decimal at this point. So that means I'll move it 1, 2, 3, 4, 5, 6, 7. So 7 places to the left. So this will become 4.9512 into 10 power 7 because I moved the decimal 7 places to the left. So this will be 4.9512 into 10 power 7. Find the percentage increase in population of Pakistan from 2014 to 2015. So this percentage increase will be the change in population, divided by the original population because in 2014. So that will be the population because we are calculating the percentage change from 2014 to 15. So population in 2014 multiplied by 100. So how much is the change in population? The change in population is, so 2015 it's 188,169,000 minus 2014 is 185,133,000 divided by the population in 2014 is 185,133,000 into 100. So your answer, let's calculate it. 188,169,000 minus 185,133,000 and then divided by 185,133,000 and then multiplied by 100. So this will be 1 point. Then I'll write it up to 3 significant figures. So I will round this 3 up to 4. So I will get 1.64%. Part E is the population of Cambodia in 2015 was this much. Given that the increase in population from 2014 to 15 was 1.68%, calculate the population of Cambodia in 2014. Give your answer correct to 3 significant figures. So let the population in 2014 equal to X. So, in 2014, population in 2014 equal to X. So the percentage increase from 2014 to 2015 was 1.68%. So population in 2015 will be 101.68%, 68% of X, where X is the population in 2014 because the percentage increase from 14 to 15 is 1.68%. So we're given the population in 2015 is this. So this will be 15,677,000 equals to, so I'll convert this percentage into the fraction 101.68 divided by 100 and then multiplied by X, which is the population in 2014. So then from this I will get X equals to, so I have 15,677,000 multiplied by 100 and then divided by 101.68. So this is 1541797, and then I have to write it up to 3 significant figures. So if I start from left, this is first, second, third. So this is my third significant figure. All the next values will be 0, and since this is 1, so 4 will remain 4. I will not round it up. So this will be 15400 and then three zeros, 400,000. So this is 15,400,000, correct to three significant figures. Question number 3 is Rowena spins two fair spinners. Each is numbered 1 to 4. Her score is the value when the numbers on the two spinners are multiplied together. The table shows some of the Rowena's possible scores. Complete the table of possible scores. So you have two spinners, each is numbered 1 to 4, and you spin them together, and you then multiply the numbers that you get on each of the spinners together to get the final score. So if you get 1 on first spinner and the 1 on second spinner, you multiply 1 by 1, you get 2, and so on. So here you have, so let's see this one. So you get 2 on one spinner and 2 on the other. So 2 times 2 is 4. So you're just basically multiplying the scores on each spinner. So 3 times 2 will be 6, 4 times 2 8. This will be 3, 3 times 2 6, 9, 12. This will be 4, 8, 12, and 16. Find the probability that Rowena's score is less than 4. So probability score is less than 4 equals to, so you have how many possible outcomes? 16. 4, 8, 12, and then 16 possible outcomes. And out of those 16, so you have denominator will be 16 of all, because 16 is your total possible outcomes. And how many of these outcomes are less than, the score is less than 4? So you have 1, 2, 3, 4, 5. So basically these scores are all less than 4. So 1, 2, 3, 4, 5. So 5 scores are less than 4. So your probability of getting a score which is less than 4 is 5 over 16. So let me just erase this. Part C is find the probability that Rowena's score is an even number. Give your answer as a fraction in its lowest terms. So probability that the score is even number. So again, your total possible outcomes are 16, and let's see how many of them are even. So this is even, these 6, 8, this 6 here. So these are all even outcomes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this one is also. So this is 12. So you have 12 scores that are even. So you get 12 over 16. And then you have to write it in its lowest form. So I can divide by 4. So 4 threes are 12 and 4 fours are 16. So your answer is 3 over 4. Part D is Phoebe says that Rowena's score is more likely to be a square number than a factor of 6. Is she correct? Show your working. So let's find the probability of getting a square number as your score. So probability that you get a square number will be equal to, again, denominator is 16 because all possible outcomes are 16. So let's mark the square numbers. So this is a square number. This is also square. And then 9 is also a square number. This 4 here. And then 16. And then this 1 is also a square number. So you have 1, 2, 3, 4, 5, 6 square numbers. So your probability of getting a square number is 6 over 16. And then what is the probability that you get a factor of 6? So probability factor of 6. So let's see. Let me mark them in yellow. So what are the factors of 6 here? So you have 6 here, and then you have 6 here as well. And then you have these 3 is also a factor of 6, 2 is also a factor of 6, this 2 as well, this 3, any other factors, and then 1 is also a factor of 6. So all these marked in yellow are factors of 6. So how many of these are there? 1, 2, 3, 4, 5, 6, 7. So factors of 6 is 7. So the hypothesis that Phoebe made was that the score is more likely to be a square number than a factor of 6. So which is not correct. So Phoebe is not correct because probability of getting a square number because probability of square number is actually less than the probability of getting a factor of 6. So getting a factor of 6 is more likely, not uh, the square number. So Phoebe is incorrect. Question 4 is you're given matrices A, B, and C. Part A is calculate 2B minus 3A. So 2B will be 2 times 5, 3 minus 2, 1 minus 3A will be 3, 2 minus 4 minus 2. So I'll multiply these numbers inside. So here I will get 5 times 2 is 10, 6 minus 4, 2. And then minus 3 times 3 is 9, 6 minus 12, and then minus 6. And then I can subtract the corresponding number. So 10 minus 9 will be 1, 6 minus 6 will be 0, minus 4 plus 12 will be 8, and then 2 plus 2 minus and minus will become plus, so 2 plus 6 will be 8. So the answer will be 1, 0, 8, 8. Part B is calculate BC. So BC will be equals to 5, 3, minus 2, 1, and then multiplied by C, which is minus 2 and 1. So this is a 2 by 2 matrix, and this has 2 rows and 1 column. So this is a 2 by 1. So the column of the first matrix are equal to the rows of the second matrix. So they can be multiplied. And if you cancel these, your answer will be a 2 by 1 matrix. So your answer will be a 2 by 1 matrix. So let's calculate that. So if I multiply this first row with this column, so I'm multiplying first row with first column. So I'll get the value in the first row and first column, which will be 5 times 2 is minus 10 plus 3. And then multiplying second row with first column, I will get 2 times 2 minus and minus will become plus 4, and then plus 1, which is minus 7 and 5. So your answer here will be minus 7 and 5. Part C is calculate A inverse plus A. So let's first calculate A inverse. So for that we will need the determinant of A, which will be 3 times minus 2, and then minus 2 times minus 4. So this will be minus 6. This and minus will become plus 8, which is 2. So A inverse will be 1 over determinant, so 1 over 2 multiplied by the adjugate of A. So we will swap the places of 3 and minus 2. So this will become minus 2 and 3. And you'll change the sign of this 2 and minus 4. So this will become minus 2 and this will become plus 4. So this is A inverse. If I take this half 1 over 2 inside, I'll get minus 1, 2, and 3 over 2. So then A inverse plus A will be, A inverse is this, minus 1, 2, and 3 over 2, plus A, which is this, 3, 2, minus 4, and minus 2. So let's add them. So 3 minus 1 will be 2, 2 minus 1 will be 1, 2 minus 4 will be minus 2, and minus 2 plus 3 by 2 will be minus 1 over 2. So this will be your answer, A inverse plus A, 2, 1, minus 2, and minus 1 over 2. Question 5 is express as a single fraction as simply as possible. So I can take the LCM, which will be 10x, the product of two, sorry, not the product, but the LCM. So LCM here will be 10x. I'll multiply this 2x by 5 to get 10x, and then I'll multiply this 5x with 2 to get 10x. So LCM is 10x, and then since I multiplied by 5 in the denominator here, I'll multiply this 1 by 5 as well. So 5 times 1 is 5. And then I multiplied this 5x with 2 to get 10x. So 2 will be in the numerator will be multiplied by 5 as well. Oh, sorry. Uh, 2 will be multiplied by 2 because I multiplied by 2 in the denominator. So 2 times 2 is 4. So this will be 9 over 10x. Simplify this expression. So I can open the bracket. So if I multiply this 4 inside, I will get 12x minus 8y plus 4. And then if I open this bracket, this minus will be multiplied. So I'll get minus 5x plus 3y minus 1. So 12x minus 5x will be 7x. Minus 8y plus 3y will be minus 5y. Plus 4 minus 1 will be plus 3. So 7x minus 5y plus 3. Part C is solve 3x squared minus 5x minus 0, giving your answer correct to two decimal places. So we can use the quadratic formula, which is minus b plus minus square root of b squared minus 4ac over 2a. So let's substitute the values. B is minus 1, so minus b will be plus 1, plus minus square root of minus 1 square minus 4 into 3 into minus 5, and then whole divided by 2 times a, which is 3. So I will get minus 1 square is 1. So 1 plus, because this minus and this minus will become plus. 5 times 4 is 20. 20 times 3 is 60. So this will be 60, which is 61. So this will be 1 plus minus under root 61 over 6. So x equals to 1 plus under root 61 over 6, or x equals to 1 minus under root 61 over 6. So let's calculate the under root here. 7.81 and then plus 1 and then divided by 6. So this will be 1.47. I'll write up to three significant figures. So this one here is 1.47, and this one here, again calculate square root of 61, and then you will do 1 minus the square root of 61, 1 minus answer, and then divided by 6. So again, I will write up till three significant figures. So this 3 will be rounded up to 4 because there's a 5. The next value is greater than or equal to 5. So this will be minus 1.14. So x is 1.47 or minus 1.14. Part D is draw the graph of x plus 2y equals to 5. So this means I can make y the subject of this equation. So I have 2y equals to 5 minus x, and y will be 5 minus x over 2. So if I have x equals to, let's take any 2 points. Let's take 0 and let's take 5 here. So y value will be 5 minus 0 over 2 will be 2.5. And then 5 minus 5 will be 0, and 0 divided by 2 will be 0. So I have 2 points, 0 and 2.5. So 0 and 2.5 is here. And then 5 and 0. 5 and 0 is this point here. So let me try to draw a straight line between the 2 points. So this will be the graph of this equation, x plus 2y equals to 5. Part 2 is shade the region defined by these three inequalities and label it R. So you have these three inequalities. X is less than equal to 3. So x is less than equal to 3 is this line. So that means towards the left of this line. Then y is less than equal to 4. That means below this line, which is y equals to 4. So left of this and below this. Y is less than equal to 2x. So if you look at this line, this is actually y equals to 2x. When x is 1, y is 2 times the value of x, which is 2. So this is y equals to 2x. So y less than equal to 2x means below this line. And then x plus 2y is greater than equal to 5. So this is your equation line that you just drew in the first part for this equation. X plus 2y equals to x plus 2y equals to 5. So the inequality here is greater than equal to. So that means above this line. So this is the region that you will shade, and you can label it R as well. So let me actually label it R. Question number 6 is triangle PQR has a right angle at P, and this angle is 38 degrees. This length is 12 centimeter. Calculate PQ. So PQ is this line. So if you take this angle, this is your base and this is your perpendicular. So you can use sine of 38 degrees will be equals to uh, sorry, you'll use, yeah, sine, which is perpendicular over hypotenuse. So you know the hypotenuse. So perpendicular is PQ that you need to find, over hypotenuse is this length QR, which is 12. So PQ is simply 12 multiplied by sine of 38 degrees. So let's calculate that. Sine of 38 multiplied by 12. So this will be 7.39 up to three significant figures. So this will be 7.39 centimeters, 7.39. Part B is S is a point such that angle PRS is a right angle and QS equals to 10 centimeter. So PR and then S will be 90 degrees. So this is a line which is 90 degrees, making an angle of 90 degrees with this PR length. So that PRS, so S can be anywhere on the line. So it can be somewhere here, such that this length QS is what? 10 centimeters. Calculate the two possible values of angle QSR. So you need to find this angle value QSR. So here you know this opposite side of this angle, and this QSR angle is this, and the opposite side is this. So if I'm looking at this triangle RQS, I know this side of the triangle. I know I need to find the angle opposite of this side, and I know this side of this triangle, which is 10. I can find this angle, which is 90 minus 38. So QRS angle is how much? It's 90 minus 38, which is 52 degrees. So this angle is 52. Now I can use the sine rule in this triangle RQS to find the angle QSR. So sine of angle QSR over the opposite side, which is 12, equals to sine of this angle, sine of 52, divided by the opposite side, which is 10. So sine of QSR is how much? This is sine of 52 divided by 10 and then multiplied by 12. So this is 0.9456, 0.9456, and then QSR will be the sine inverse of this. So if I take sine inverse of this, I get 71.0. So up till first decimal place. Remember, when you have non-exact answers for angles in degrees, you have to write up till first decimal place. So this angle here will be 71.0 degree. And since we know that the sine of this angle is positive, and we know that sine is positive in the first quadrant and in the second quadrant, and we also know the property that sine of theta equals to sine of 180 minus theta. So if this angle is 71 degrees, the other possible value of QSR will be 180 minus 71, which is 109.0 degrees. So the two possible values of this angle QSR is 71.0 degrees and 109.0 degrees. So if you take sine of this, you will get this. And if you take sine of 109, you again get the same answer back. So these two will be your answers for this question. So question 7 is the diagram shows patterns made from crosses and circles. Draw pattern 5 above. So here, if you look at the pattern, you have one cross here, then you have this cross as it is, and then you add another one to the top and bottom. And now you have two crosses in this diagonal here. So you keep those two and then add another one. So you have three now. And in the next pattern, you have those three and then you add another one, which is the fourth one. So if I have four here, so that means in the next pattern, I'll draw these four and then add another one because there will be five in the fifth pattern. And you just do repeat the same below as well. So let's draw this. So this will be 1, 2, 3, 4, and then fifth one on the top, and then similar 1, 1, 2, 3, 4, and 5. And then you can complete the rows. So in fact, let me draw this properly. It should be here below. And then you can complete the rows. So in the rows, you can see that you alternate between, so you start with cross, then circle, then cross. So you alternate between circle and cross. So this will be circle, circle and cross, circle, cross, circle, circle, cross, circle and cross, cross, and then circle, cross, circle, cross, and circle, and then cross, and then cross, circle, and then you finish up. So rows is pretty simple. You just have to alternate between cross and circle to complete these. So the next part is the table shows the number of crosses and circles in each pattern. So you have to complete the table. So you have to find the number of crosses and circles in pattern 5. So if you look at this, you add 2 here to get the next one. And the next time you do add 3 here. So you added 2, then you add 3, then you add 4 to get 10. And that means you will add 5 next to get 15. So if it's not clear, you can also count the crosses. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So 15 crosses. And then for circles, again, you're doing same. You're adding 1 here. Then you're adding 2 plus 2. Then you're adding 3. So that means you'll add 4 here to get 10. And you can also count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then similarly, pattern 6, you haven't drawn it, but you can use this sequence. So you added 5 here. Now you will add 6. So 15 plus 6 will be 21. Here you added 4. The next time you will add 5. So you will get 10 plus 5, 15. So this is how you will complete this table. Part C is find an expression in terms of n for the total number of crosses and circles in the pattern. So if you look at this, this is pattern number 1. You have total number of 1 crosses and circles. Here you have 4 crosses and circles, 9 crosses and circles. So if you look at, compare the pattern number with the total number of crosses and circles, you see that these are squares. So 2 square is 4, 3 square is 9, 4 square is 16. So this answer here will be n square. So you simply take the square of the pattern number to get the total number of crosses and circles in that pattern. Part D is an expression in terms of n for the number of crosses in pattern n is given. How many crosses are there in pattern number 30? So number of crosses in pattern 30 will be equals to, so you're given the formula for the crosses in pattern n, so you will simply substitute 30 in place of n. So you'll get 1 over 2 30 square plus 1 over 2 into 30. So 30 square is 900, and then 900 divided by 2 is 450, plus 30 divided by 2 is 15. So this will be 465. The next part is show that the number of circles in pattern n is this. So you know that the sum of crosses and circles is n square, and then you also know that the number of crosses is this. So you can simply use the equation to sum, like you can add the number of crosses and then add the number of circles, and you should get total number of crosses and circles. So using this equation, total number of crosses and circles equals to number of crosses plus number of circles. So total number of crosses and circles is what? N square. Number of crosses is this given in the previous part, 1 by 2 n squared plus 1 over 2n, and plus number of circles is what you need to find. So this is the unknown. So number of circles will be simply, you take everything to the other side. So you get n square minus 1 over 2n square plus 1 over, oh sorry, minus 1 over 2n. So you're taking it to the other side of the equation. So this will become negative 1 over 2n. So n square minus 1 by 2n will be simply 1 over 2n square minus 1 over 2n. So this is how you will show this. Part F is the number of crosses in pattern M is equal to 5m. So number of crosses in pattern M will equal to what? So you know that the number of crosses in pattern N is given by this. So you will simply substitute M in place of N here. So you will get 1 over 2 M squared plus 1 over 2 M. And here you're given that this number of crosses is how much? 5m. So you'll substitute 5m here. So you will get an equation in M. And you can solve this to find the value of M. So let me just multiply it by 2 on both sides so I can get rid of these fractions. So if I multiply by 2 on both sides, I will get 10m equals to m square plus m. And if I bring this 10m to this side, I will get m square plus m minus 10m equals to 0. And this will be m square minus 9m equals to 0. And then I can take m common. So let me continue here. So I will get m into m minus 9 equals to 0. So that means m equals to 0 or m equals to 9. So m equals to 0 is not applicable because your pattern number will start from 1. There's no like pattern number 0 here. So your answer here is the value of m is 9. So you always start with the first pattern, the second pattern. There is no like 0th pattern, so m cannot be 0. So the value of m is 9 here. The next question is ABCD is the cross section of a building. All the lengths are given in meters. So the lengths are given. These two are 90-degree angles. Calculate the length DC. So DC is this length here. And so if I look at this length, I am given 15.1. So if I draw this, if I draw a line parallel to this, so if I create a rectangle, so let's say I draw a line from this point, from B, and this line is parallel to this line DC. So it will be something like this. So this length will also be the same as DC. These angles will be 90 degree as well. So this will be kind of a rectangle. So we know that this length here is 4. So this length here is 4. So this length here will be 6 minus 4, which is 2. So now I can calculate this length using this triangle here. This angle is also 90 degrees. I can use the Pythagoras theorem. So using the Pythagoras theorem, this is the hypotenuse and this is the base and this is the perpendicular length. So hypotenuse square, which is 15.1 square, will equal 2 square plus DC square plus DC square. So this length here, the blue line that I just drew, this is equal to the length of DC. So DC square, I can actually make DC the subject. So DC will be 15.1 square minus 2 square is 4 and then under root. So let's calculate this. So 15.1 square minus 4 and then under root of this answer will give you the length of DC. So this is 14.96696. So this is a non-exact answer. So I have to write up till 3 significant figures. So 14.9 will be 3 significant figures. Then the next value is 6. So this 9 will be rounded up. So I will get 15.0 meters. So answer here will be 15.0. The next part is calculate the angle EAB. EAB is this angle. So I can use the cosine rule because I know the 3 sides of this triangle EAB. All 3 sides are known, and I can use the cosine rule to find this angle EAB. So the cosine rule will be cos of EAB will be equal to the sum of the square of the 2 sides that make the angle, which will be 9 square plus 11 square, and then minus the opposite length of the angle, which is 15.1 square, and then divided by 2 times 9 times 11. So cosine of EAB will be, let's calculate this, 9 square plus 11 square minus 15.1 square, and this divided by 2 into 9 into 11. 2 into 9 into 11. So you'll get minus 0.13136, and EAB will be simply the cosine inverse of this. So let's take cosine inverse, cos inverse of this answer. So this is 97.54. Again, this is a non-exact answer, so you will write up till 1 decimal place. You write the angles up to 1 decimal place. So up to 1 decimal place, this will be 97.5 degrees. Part C is calculate the area of the cross section. So to calculate the area of this cross section, so let me just erase this. This will be simply the area of this trapezium EDCB. This is a trapezium, and then area of the triangle EAB. So to calculate the area of trapezium, I know this length is DC is 15 that I have calculated in the first part. So I know the height, I know the 2 parallel sides, so I can easily calculate the area of this. For the triangle, I can use the formula 1/2 into this length 9 multiplied by this length 11, and then sine of the angle between them. So I've also calculated this angle to be 97.5. So I can add the two areas together to get the area of the total cross section. So area of the cross section will be equal to area of trapezium EDBC plus area of triangle EAB. So area of trapezium is 1 over 2 into height, which is 15, multiplied by the sum of parallel sides 6 and 4. So 6 plus 4 plus area of triangle EAB will be 1 by 2 into 9 into 11. 1 over 2 into 9 into 11 into sine of this, sine of 97.5. So 6 plus 4 is 10. 10 divided by 2 is 5, and 15 times 5 is 75, plus this. So let's calculate this. Sine of 97.5 multiplied by 11 multiplied by 9, and then divided by 2. So this is 49.0675, 49.0765, and then plus 75. So this will be 124.076. So up to 3 significant figures, this will be 124. So 124 meters square will be the area of the cross section. Part C is a model of the building is made using a scale of 1:50. What is the area of the cross section of the model? Give your answer in square centimeters. So you have model ratio real building. So what is the ratio? Uh, in in the real world, 50 centimeters is represented by 1 centimeter. So 1 centimeter in the model represents 50 centimeter in the real building. So since we are looking at the area here, so first I will convert this into meters because the area that I have here is in meters. So if 1 centimeter in the model is 50 centimeter in the real building, then 1 centimeter in the model will be 50 over 100 meters, since 1 meter is 100 centimeters. And then since I'm looking at the area, then I'll take the square on both sides. So this is, so let me just simplify it first. So 1 centimeter is zero point 0.5 meter in the real building. So then 1 centimeter square, so I take the square on both sides, 0.5 meter square. So that means 1 centimeter, 1 square is 1. 1 centimeter square is how much? 0.25 meter square. So 1 centimeter square area in the model is 0.25 meter square in the real building. So I need to convert this area of the real building into the model. So 1 meter square will be how much? 1 meter square will be 1 over this 0.25. I'll divide by 0.25 here. So I will get 1 over 0.25 centimeter square. So 1 meter square in the real and then model here. So this, you can use equal sign or ratio sign is fine as well. So 1 meter square is 1 over 0.25 centimeter square in the model. So how much is 124? So area in the model will be equal to 1 over 0.25 multiplied by what your actual area is 124. So 124 divided by 0.25, you get 496 centimeter square. So 124 meter square in the real building will represent 496 centimeters square in the model of that building. Question number 9 is a random number x is generated where x is any real number. Manuel adds 2 to x. He subtracts x from 10. Manuel then multiplies these two results to give his number y. So this is the first number that he gets, and this is the second number that he gets, and then he multiplies 1 into 2. So 1 will be multiplied by 2 to get the number y. So 1 multiplied by 2 will be y. Yeah. So show that y is this. So what is the first number? First number is he adds 2 to x. So this is x plus 2, x plus 2. And the second number is he subtracts x from 10. So this will be 10 minus x because x is being subtracted from 10. And then he multiplies these two numbers. So this is 1, this one, and this is 2, this one. And then he multiplies the 2. So if you open this bracket, so y will be this number, the product of 1 and 2. So now we can open this bracket to show that y comes down to this. So y will be, if I open the bracket, I get 10x minus x squared. And then if I multiply 2 with this 10, I get plus 20 and then minus 2x. So this will be, y will be 20. Then 10x minus 2x is plus 8x and this minus x squared. So you have shown that y is this. On the grid opposite, draw the graph of y equals to 20 plus 8x minus x squared for x between 0 and 10. 4 points have been plotted for you. So you're given the values at x equals to 0, x equals to 1, x equals to 9 and 10. So that means you need to calculate the values from 2, 3, 4, 5, 6, 7, 8. 9 and 10 are given. So we can quickly create a table here. So x values are 2, 3, 4, 5, 6, 7, and 8. And then y equals to 20 plus 8x minus x squared. So we can calculate the corresponding values of y here. So when y is 2, this will be 20 plus 16. 8 times 2 is 16. And then minus 4. 2 square is 4. So this will be 32. The next value is 3. So this will be 20 plus 8 threes are 24 minus 9. This will be 35. And then the next one will be 20 plus 8 times 4 is 32 minus 16. This is 36. Then 20 plus 8 times 5 is 40 minus 25. This is again 35. Okay, the next value is 6. So 20 plus 48 minus 36. This will be 32. And then 20 plus 8 times 7 is 56 minus 49. This will be 27. And when it's 8, so it will be 20 plus 8 times 8 is 64 minus 8 square is also 64. So 64 minus 64 will be 0. So this will be simply 20. I don't need to calculate this. So now we can plot these points and then plot the curve. So 2, when x is 2, you have y value is 32. So x is 2 here. So each small block here represents a value of 0.5 because there are 10 blocks and the value changes by 5. So 5 over 10 is 0.5. So this is, so the value I'm looking for is 32. So 32 will be, this is 30, this is 31, and this will be 32. 32 will be this one. 31, 32, yeah. 33, 34, and then 35, yeah. So this will be 32. The next one is 35, 3 and 35. 35 will be this one. At 4, you have 36. 4 and 36 will be this one. 5 is 35. 5 is 35. Then 6 is 32. 32 is this one. 7 is 27 and 8 is 20. 7 is 27. So 30, 29, 28, 27 is this one. 7 is 27 and then 8 is 20. 8 is this value. So now you can draw the graph of this equation. So let's draw this. It will start at this point. Somewhat like this. I messed it up a little bit at the end, but you get the idea. So this will be your graph. Part C is, on the same grid, draw a suitable line to find the value of Manuel's number y when it is the same as the random number x. So random number x is here and y values are plotted. So on the y-axis you have the y values, which is the number Manuel generates by multiplying these two numbers, and x is the random number that is initially generated. So you're looking for a point when y is the same as the random number x. So for example, if you look at this point here, your x value is 8 and your y value is 20. So this is not the point where x and y values are same. So basically you're looking for a point on this curve where both the x and the y value are the same. So rather than moving up and down on this curve trying to find that point, so for example on this point your x value is 9 but your y value is 11. So what you can do is, yeah, so this is 9 and this is 11. So that means it's somewhere down here where both the x and y values are same. So an easier way to find that point will be, you can draw a line which has the equation y equals to x, and wherever that line intersects this curve, you will get that point where both values, x and y values, are the same. So let's plot a couple of points for y equals to x. So if x is 2, y is 2 as well. So this is 2, 2. This point is 2, 2. And then you can plot another one, 8, 8. So 8, 8 will be, this is 8 and this is 10. This will be 9 and this will be 8. So this point is 8, 8. So these 2 points lie on the equation y equals to x. And of course you have 0, 0 as well. So now I can draw a straight line which joins these points and see where it intersects the curve. So make sure you draw it all the way till the end and you like this. So this is your line y equals to x, and this is the point of intersection. So you have to find what is the when it is the same on the same grid, draw a suitable line to find the value of Manuel's number y. So you're looking for the y value. So y value is exactly the same as the x value. So if you look at this point here, this is the point of intersection. So you have to find the y value. So y value is it's like in the middle of this small block. So I can draw a dotted line like this in the middle here and see what is the value of y. Basically trying to keep it as straight as possible in the middle here. So this will be 10, this is 9, so this is around 9 point, you can say it's a little below the middle, so maybe 9.4. So your answer is 9.4. This is the point where the value of y and x is the same. The next part is Jolene multiplies the random number x by 5 and then adds 2 to give her number z. So z is what? First, the number x is multiplied by 5, so you get 5x, and then you add 2 to it to get z. So this is your number z. Calculate the possible values of x when Manuel's number y and Jolene's number z are the same. So you have z here and y you have already seen in the previous part. Y is this 20 plus 8x minus x squared. So y is 20 plus 8x minus x squared. 20 plus 8x minus x squared. Okay. So now you're looking for a value of x when both y and z are equal. So that means I can substitute this y into this equation or equate these two. So you're looking for y equals to z, right? Stated here when y and number z are the same. So y equals to z means, so I can substitute the values of y and z here. So y is what? 20 plus 8x minus x squared, and z is on the other side 5x plus 2. Now I can solve this equation to find the values of x. So let's take everything to the right side. So I will get positive x squared. This 8x will be negative, so 5 minus 8 will be minus 3x. And this 20 will go there, become minus 20. 2 minus 20 will be minus 18 equals to 0. So now I can use factorization to find the values of x for this quadratic equation. So the factors of since this is a negative sign, so minus 18 multiplied by the coefficient of x square is plus 1. So that I will get minus 18. The product of this number and the coefficient of x will be minus 18. So I'm looking for factors of 18. When I subtract them, I should get minus 3. Why subtract? Because you know that once if you have if you get the product as negative when you multiply this number with the coefficient of x, if it's positive you look for the sum, if it's negative you look for the difference, or you subtract the factors such that you get this number in the middle. So using factorization, I can write this as minus 6x minus 3x, because if I multiply 6 into 3, I get 18. Sorry, this will be plus. And I am subtracting these two to get minus 3. So plus 3x minus 6x will give me minus 3x. So the product is 18, and the difference, or when you do the subtraction is this minus 3x. And then I can take x common here, so x into x minus 6, plus I can take 3 common here, x minus 6. So x minus 6 is common, so this will become x minus 6 times x plus 3 equals to 0. So the two possible values of x will be x equals to 6 or x equals to minus 3. So the values will be 6 or minus 3. Question number 10 is the diagram shows the position of point A. Point B is 8 centimeter from A on a bearing of 0.62 and point C is 6.5 centimeter bearing 194 from A. Find and label B and C. So B has a bearing of 0.62 degrees from A. That means if you start from north of A, you will have to make an angle of 62 degrees, and then the distance of B is 8. So first I will mark the angle, then use my ruler to calculate the distance. So since I'm measuring 62 degrees, so let me just align my protractor here. So I'll center it at A, then make sure your zero line is aligned with the north. So I have 180 here, so that means I will move 62. So this will be 10, 20, 30, 40, 50, 60. So this 120 mark makes an angle of 60 degree with the north. So 118 will be 62 degrees from the north. So this point here will be 62 degrees. And then I have to measure a distance of 8 centimeter. So I'll use my ruler here to mark 8 centimeters. So first I will align it with my point so that the angle is correct. And then 0 at A, and 8 centimeter will be this point here. This is it. So this point, this will be point B. And now for C, you have to draw a point which is 6.5 centimeter from A and bearing is 194. So that means 194 is this angle. So this angle, if I go anti-clockwise from north, will be 360 minus 194. So this angle here will be 166 degrees. So since my protractor only goes up till 180, so I have to find the other angle because 194 is greater than 180. So the other angle is 166. So now I will align it like this, position it at A, and then align my zero here. So 166 is this point, 160, 165, and 166 is this one. So now I can again use my ruler to find a distance of 6.5 centimeters. So let's align it like this, then position it at 0. So 6.5 centimeters will be this point here. So this point here is C. So you can just erase the other two marks that you made for the angles. So these are your points B and C. The next part is point D is the point on BC, that is the shortest distance from A. Find and label D. So first you have to draw this line BC and then see where is the point which has the shortest distance from A from that line BC. So let's first draw this line here. Let me connect these points. So this will be your line BC. And now you have to find the shortest distance of A from this line BC. So the shortest distance will always make a angle of 90 degree. So here I can use my set square and find where this point A, line from point A when it joins with this line BC, where does it make an angle of 90 degree? So let me first align my set square with this line BC. So see, all right, so now it's perfectly aligned. So this line, if I draw a line like this, it will make an angle of 90 degree with this line BC. So let's see where that 90-degree line joins point A. So this will be the line. If you draw this, this is the shortest distance of A from line BC, and this will be your point D where it intersects BC. So point D is the point on BC. So this is on BC. That is shortest distance from A. So this point here, D, is shortest distance from A because this angle here is 90 degrees. The next part is measure the length AD. So let's measure it using our ruler here. So first I will again align it, the line, and then if I place my 0 here at A, it's almost 2.8 centimeters. So the length AD is 2.8 centimeters. Part 4 is by taking measurements, find the ratio CD ratio DB. So CD is this length and DB is this length. Give your answer in the form 1:n. So first we need to measure these two lengths. So let's align the ruler with this now, like this. Place 0 on this point. So CD is almost 5.8 centimeters. So I can write it here. CD ratio DB. So CD is 5.8. Ratio DB, let's measure DB now. So DB will be this length here. So DB is almost 7.4 centimeters. So oops, this length DB will be 7.4. So you have this ratio 5.8 ratio 7.4. So you have to give your answer in 1:n. So this is CD ratio DB. So 1:n, I will divide 5 by 5.8 on both sides of the ratio. So 5.8 divided by 5.8 will be 1. And here I will get 7.4 divided by 5.8. So this will be 1 ratio. So let's calculate 7.4 divided by 5.8. So this is 1.2758. So you have to give the answer up till three significant figures. So this will be 1.28. So 1:1.28. So 1:1.28. Part 5 is the area of triangle ADB is W centimeters square. So ADB. So let me actually draw this line as well so you can get an idea of the rectangle. So this is your triangle ADB, right? So the area of triangle ADB is this triangle is W centimeter square. Giving your answer in terms of W, find the area of triangle ADC. So ADC is this triangle here. So let me just draw this line as well so that it's easier to visualize this. So this is your triangle ADC. So you have to find the area of this triangle in terms of W, given that the area of ADB is W centimeter square. So if this angle is 90 degree and this is a straight line, this angle is also 90 degrees, right? So if you want to find the area of this triangle in terms of W, you need one of the lengths of this triangle in terms of W as well. So what is the area of triangle ADC? So I can write area of triangle ADC is what? 1 by 2 into base. Base is this length CD and height is this length AD. And if you look at this height length AD, it is common between these two triangles. So I can find this height AD in terms of W using this triangle ADB because I know that the area of this triangle ADB is W centimeter square. So using area of triangle ADB equals to 1 by 2 into AD into this length dB. So you know that area is W, 1 by 2 into AD into dB. So what is AD? AD is 2 times W over this length dB. So I can substitute this AD in this equation. So I will get 1 by 2 into CD into AD is what? 2W over dB. 2W over dB. So this 2 and this 2 will cancel out. So I will get CD over dB into W. CD over dB into W. So this CD over dB I already know is 1 over 1.8. 1 ratio 1.28. So this is 1 divided by 1.28. 1 divided by 1.28 into W. So this is CD. If it's 1, dB is 1.28. You calculated this ratio in the previous part. So let's calculate 1 divided by 1.28. So you get 0.781 up till 3 significant figures. So this will be, so let me just draw this line here because this was previous part. So this is previous part. So this will be 0.781 W centimeter square. So this answer will be 0.781 W centimeter square. So that's how, using this common height of the two triangles, we first calculated this AD in terms of W because we know the area of this triangle, and then use that value of AD, which is in terms of W, to calculate the area of this triangle. Remember, you cannot use the property of similar triangles because it is not given that these two triangles are similar. So you have to use this method where you take this common length, common height of the two triangles to calculate the area in terms of W. Or another method could be that you can calculate the area of this triangle ACB using 1 by 2 into base will be BC and height will be AD. You can measure them. And once you have the area of this full triangle, you can minus this W centimeter square, which is this area of ADB. And then the resulting answer will be, the remaining answer will be the area of this triangle ADC. So that's another method that you can use to calculate this area in terms of W. Part B is the diagram shows positions of A, E, and F. Construct and shade the region inside the triangle AEF. So inside this triangle, that is less than 6 centimeter from E, nearer to AF, then to AE, nearer to A, then to F. So we can go through these conditions one by one. So the first condition is the shaded region should be less than 6 centimeter from E. So we can draw a locus of points that is 6 centimeter away from this point E, and anything closer to E than that locus of points will be less than 6 centimeter from E. So the locus will be a circle of radius 6 centimeter. So let's draw the circle. So I'll use my compass here. I will open it up till 6 centimeters, then position it at this point E. And since we are only interested in uh, the region is only inside this triangle AEF, so I'll only draw the locus inside this triangle. So that means I will start from this point here and then go all the way up till this line here. So I'll remain in this triangle. So this is the locus of points that are 6 centimeter away from E. So anything towards the left side of this arc is less than 6 centimeters away from E. The next condition is nearer to AF than to AE. So this is your line AF, this is your line AE. So nearer to AF means if I draw an angle bisector of this angle A, the points on that angle bisector will be equidistant from AE and AF. So all the points that are on the right side of that angle bisector will be closer to AF. So let me draw the locus and explain, and that way you guys will have a better idea. So to draw the angle bisector, I will open up my compass to any arbitrary length, and then I will place it at the angle for which I'm drawing the angle bisector, and then I will draw an arc from the two lines that make that angle. So AF and AE. So I'll draw an arc from line AF. So let me make sure it's centered at A like this. So this will be my arc from AF up till AE. Then without changing the length of the compass, position your compass on the point where the arc intersects the line, and then draw another arc like this. And then again, without changing the length of the compass, position it at the other point where the first arc intersects the other line. So this will be that point. And then I will draw another arc like this. Now, if I join this point, which is made by these two arcs, with this point A, I will get the angle bisector of this angle FAE. So let's do that. I'll use my ruler here, align it with this point here. And remember, since we only have to draw inside the triangle, so I'll start with point A and go up till the line EF on the top. So this will be my angle bisector of angle FAE. So this line, all the points on this line are equidistant from AE and AF. So anything towards the right side in this region will be closer to AF than to AE. So the third condition is the region is nearer to A than to F. So nearer to this point A compared to this point F. So that means if I draw a perpendicular line bisector of this line AF, the points on that perpendicular bisector will be equidistant from F and A. So anything towards the anything below that line bisector will be closer to this point A. So first we need to draw the perpendicular bisector. So to draw the perpendicular bisector, I will place my compass at this point A, and then you have to open the compass to a length which is greater than half the length of the line that for which you are drawing the line bisector. So this is more than half the length of this line AF. So I will draw two arcs. So let me position it at this point A, and then I will draw two arcs, one on either side of the line AF. So this will be my first arc, and then on the other side I will draw another arc like this. And then without changing the length of the compass, position it at the other point F. So I'll center it at F and then again draw two arcs, on one on the either side of this line AF. So one below the line and the other one on the other side like this. So now if I join this point with this point, I will get the uh, line bisector of this line AF. So let's do that. So I'll align my ruler like this. So again, I only need to draw inside this triangle because I'm only interested in the regions inside the triangle AEF. So this is your uh, line bisector for this line AF. So let's look at these condition again. So the region that is shaded is less than 6 centimeter from E. So this arc is 6 centimeter from this point E. So that means we are looking for a region on the left side of this arc. So all this region is is less than 6 centimeter from E. The next one was nearer to AF than to AE. So this is your angle bisector of this angle A. Anything towards this side of this angle bisector will be closer to AF because this is like the midpoint. All the points on this line are equidistant from AE and AF. So anything towards this right side will be closer to AF. And then nearer to A than to F. So this is your line bisector of AF. So all the points on this line are equidistant from A and from F. So anything towards this side of this line bisector will be closer to A. So this is the region that you get. So all the points in this region will satisfy all these three conditions. So this is the region that you need to shade like this. The next question is the table below summarizes the time taken by 50 athletes to run 400 meters. So you have time in seconds and frequency. So that this shows that 7 athletes took a time between 50 and 55 seconds. 16 took a time between 55 and 60 seconds to run 400 meters and so on. Part one is state the model class. So the model class will be the one which has the highest frequency. So which is this one. So this will be your model class, greater than equal to 55 but less than 60. Part two is calculate an estimate of the mean time taken by these athletes. So since you do not have exact values here for these frequencies, you have ranges. So what you do is you calculate the midpoints of these ranges. So I'll draw another table here. So let's first write these values as well. So you have time in t seconds, and then you have you can calculate the midpoint for that class. So you have midpoint, then you have the frequency. Let's call it F. Let's call midpoint X. And then you have the product of the frequency and the midpoint. So product will be F times X. So let's complete this table here. So you have class here 50 t less than 55. So your midpoint here will be, what's the midpoint between 50 and 55? 50 plus 55 divided by 2, 52.5. What's the frequency? 7. So I'll calculate the products later. And then the next one is 55 till 60. 55 t less than 60. So the midpoint here will be 57.5. The frequency is 16. Then you have 60 till 65. 60 T 65. The midpoint here will be 62.5. The frequency is 15. Then the next is 65 to 70. The midpoint here will be 67.5 and the frequency here is 11. And then the last one is this one, which is 70 till 75. The midpoint here will be 72.5 and the frequency F is 1. So this product will be 72.5. Let's calculate these products. So 52.5 into 7, 52.5 into 7 is 367.5. 16 times 57.5. 16 times 57.5 will be 920. Then 15 times 62.5. 62.5. 937.5. Then 67.5 times 11. 67.5 into 11. 742.5. So now your mean value will be the sum of all these products. So you add them all divided by the sum of the frequencies, which is actually the total number of athletes. So if you add these frequency up, you will get 50. So your denominator will be 50, and in the numerator, you're basically calculating the sum of all these products. So let's calculate this starting from the top. 367.5 plus 920 plus 937.5 plus 742.5 plus 72.5. So this will be 3040. Then divide by 50. So 60.8 will be your mean value. So 60.8 seconds. Part 3 is calculate the probability that an athlete chosen at random took less than 60 seconds to run 400 meters. So the probability will be number. So this probability that you have to find will be equals to number of athletes who took less than 60 seconds, divided by the total number of athletes, which is 50. So how many athletes took less than 60 seconds? That will be this plus this. So these two classes represents the athletes who took less than 60 seconds. So these took between 50 and 55. These took greater than equal to 55, but still less than 60. So all these classes, the athletes took more than 60 seconds. So you will have 16 plus 7 divided by 50, and 16 plus 7 will be 23 over 50. So part B is the cumulative frequency curve summarizes the time taken by 80 boys to run 200 meters. So on y-axis you have cumulative frequency, and on x-axis you have time in seconds. Part 1 is find the median time. So to find the median time, first you need to find the 50% of cumulative frequency equals to 50 by 100 into the total value. The total number of boys who took part in this race were 80. So 80. So 50% of 80 will be 40. So you'll see what's the time value at cumulative frequency value of 40. So this is the line representing 40, and it intersects the curve at this point. So it's two small boxes to the left of this 35. So this value. So This is, so each small box represents a value of 0.5 because there are 10 boxes between 30 and 35. So 5 over 10 is 0.5. So each small box represents a value of 0.5. So this is 35, this is 34.5, so this is 34. So median is 34. Find the interquartile range. So first you need to find the 75% of cumulative frequency, which will be 0.75 into 80, which is 60. So upper quartile will be when cumulative frequency value is 60, and lower quartile will be 25% of the cumulative frequency, which will be 0.25 into 80, which is 20. So upper quartile will be what? What's the value when cumulative frequency is 60? It's this one here. So this here. So this is 35, 36, 36.5. 35, 36, 36.5, yeah. So upper quartile is 36.5, and then lower quartile is when cumulative frequency is 20, which is this one here. And this is the point where it intersects the curve. So this one point will be, this is 30, 32, 30, sorry, 31. This is 31, 2 blocks away, then 4 blocks away, it's 32. So lower quartile is 32. So interquartile range will be simply the difference minus 32, which is 30, oh, sorry, 4.5. So interquartile range is 4.5 seconds. Part 3 is 60 girls also run 200 meters. So the girl who took the longest time to run 200 meters is 40 seconds, and so on. So draw the cumulative frequency curve on the grid above. So we will use these statements to plot the points for the cumulative frequency curve. So the first statement is the girl who took the longest time ran 200 meters in 40 seconds. So that means the highest time taken is 40 seconds, and there were 60 girls. So this point will be 40, and on the y-axis it will be 60, because once you reach 60 you have covered all the girls. So all the girls run under less than equal to 40 seconds. So there were 60 girls, so the cumulative frequency at 40 will be 60. There's no girl who took more than 40 seconds to complete this race. So this is your first point. The next point is the girl who took the shortest time ran 200 meters in 28 seconds. So that means the shortest time is 28 seconds. So on the x-axis you have 28, and on the y-axis you will have 0, because there is no girl who ran less than 28 seconds. So at 28 your cumulative frequency is 0. After that your cumulative frequency curve will start to go up, because there is no girl who took a shorter time, shorter than 28 seconds. So let me just erase this here. So let's mark, in fact, let me mark these in red. So this is the first point. So 28 will be, this is 30, 29, and 28. So 0 and 28, like this. The lower quartile for the boys and the girls is the same. So lower quartile that we calculated was 32. So lower quartile is same. So that means let's first calculate 25% of cumulative frequency total. Cumulative frequency here is 60. So 25% of 60 will be 0.25 into 60, which is 15. So the lower quartile is same. So that means this point will be the lower quartile, which is the time on x-axis. The value is 32, and the cumulative frequency at that point is 15. So 31, 32. Oh, sorry. On x-axis, you have 32, this one. And on the y-axis, you have 15. So 10, 12, 14, 15. So each small box here represents a value of 2. So 10, 12, 14, 15 will be in the middle of this small block here. And the last part is the interquartile range for the girls is 4 seconds. So upper quartile will be equals to the lower quartile, which is the same as the boys, 32, plus their interquartile range is 4, which is 4 here. So 36 is the upper quartile. And then what is 75% of 60? 0.75 into 60 will give you the cumulative frequency value, 45. So this will give you, on x-axis, you have the upper quartile, which is 36. And on the y-axis, you have the cumulative frequency value, which is 75% of 60, which is 45. So this point will be 36 and 45. So this is 35, this is 36. And then you go up. This is 40, 42, 44, and 45 here. So these four statements will give you these four points. 28 and 0. This is 32 and 15. This is 36 and 45. And this is 40 and 60. So now we can join these to form the cumulative frequency curve. So start off like this. So this will be the cumulative frequency curve for these results given. So the next question, question number 12. OAB is a sector of the circle. Radius is 10. This angle here is 72. C is the point on this arc AB, such that this OC bisects this angle. So this angle is half, which is 36, and this angle is also 36. Calculate the perimeter of sector OAB. So this perimeter of sector OAB, it will be this radius, which is the length OA, plus arc AB, plus this radius OB, plus OB. So this OA is 10, plus this arc length will be angle over 360, 72 divided by 360 into 2 pi r, and r again is the radius, so radius is 10, plus this length OB is again 10. So let's calculate this middle value here. So this will be 72 divided by 360 multiplied by 2 pi into 10, and then plus 10 plus 10, so that is 20. So I'll add 20 here. So this is 32.6 centimeters. So you have to write it up till 3 significant figures. So this will be 32.6. Part B1 is calculate the area of sector OAB. So area of sector OAB will simply be angle over 360, 72 divided by 360 into pi r square. R is the radius, so 10 square. So 72 divided by 360 into pi into r square. 10 square is 100, so I'll multiply by 100 here. So this is 62.8. So again, I will round it up till this three significant figures. So this will, the answer will be 62.8 centimeters square. B2 part is calculate the total shaded area. So this is the shaded area here. So to calculate this shaded area, I know the area of the full sector. I can subtract the area of these triangles. So OAC is the triangle, and then OCB is the same congruent triangle because both of these angles are 36 degrees and their lengths are, all sides are same as well. So if I find the area of this triangle, the area of this triangle is also equal to the this one. So I can simply calculate the area of one of these triangles and multiply it by 2. And once I have the area of these two triangles, I can subtract it from the area of this full sector. So that will give me this shaded region area. So shaded area will be equal to area of sector OAB minus 2 times area of triangle OAC. OAC. So you already know the area of sector OAB. You've calculated it in the previous part. So this will be 62.8 minus 2 times area of this triangle OAC. So 2 times 1 by 2 into this length is 10. This length is also 10. This length dotted line here is also a radius because this point C is on this arc. It's given. So 1 by 2 into 10 into 10 into the sine of the angle between the two sides. So I'm taking this side OA and this side OC. So the angle between them is 36. So sine of 36. So this 2 and this 2 will cancel out. So sine 36 multiplied by 100. So sine 36 multiplied by 100 and then 62.8 minus the answer. So this gives you 4.02 up till three significant figures. So area of shaded region here is 4.2 centimeters square. So this will be 4.02. Part D is, part C is, D is the point on the arc such that angle AOD ratio angle DOB is 1:2. So you have divided this angle AOB into 1 and 2 parts. So this is 1, this is ratio 2. So 1:2 is like this. So that means angle AOD is 1 by 3 of this full angle 72 degrees. So if this full angle is 3 parts, you have divided 1 part here and 2 parts here. Gavin says that the shaded region on this diagram is the same as the shaded region in part B2. So part B2 you calculated this. Is he correct? Show your working. So we can calculate the area of this shaded region now, this here and this, and compare it with the shaded region area that we calculated in the previous part and see if they are same. So to calculate the area of this shaded region, again, I will do the same. I know the area of this full sector OAB. I calculated it here. So this is the area of sector OAB. So let me just write it down here. Area of sector OAB that you calculated in the previous part was 62.8 centimeters square. So now the area of shaded region is this area of sector minus area of this triangle AOD minus area of triangle DOB. So let's first calculate the area, these areas of these two triangles. For those we need, so this is 10, this is also 10 because this is also the radius. All we need to find are these two angles. So this angle here and this angle here. So this full angle is 72 degrees and we know that they are divided in 1:2. So that means the angle, so angle AOD equals to 1 over 3 of angle AOB. 1 by 3 times AOB, because this is one part, this is two parts, and the total is three parts. So this is 1 over 3 of this full angle, 72. So this will be 1 by 3 into 72, which is 3 times 2 is 6, 112, 24 degrees. So this angle here is 24 degrees. And then we can also find the angle DOB. So angle DOB is 2/3. So this is 2 over 3 of angle AOB. So 2 over 3, 2 divided by 3 into 72. So this is 2 over 3 into 72, which is 48 degrees. Now I can calculate the area of these triangles. So area of triangle AOD will be 1 by 2 into this side 10, this side 10, and sine of angle between them. So 10 into sine of 24. So sine of 24 multiplied by, so 10 times 10 is 100, 100 divided by 2 is 50. So I'll just simply multiply it by 50. So this area up till three significant figures is 20.3. And then area, so this is also area of triangle DOB. So area of triangle DOB will be again 1 by 2 into 10. This side is 10, this side is also 10. Both are the radius. So 10 into 10 into sine of this angle, which is 48. 48 degrees. So this is degree. So this will be sine of 48. So again, sine of 48 multiplied by, this will be 50. So sine 48 multiplied by 50. So this will be 37.2. So this is centimeter square. This is also centimeter square. Now we can calculate the area of shaded region. Area of shaded region will be the area of sector 62.8 minus this area of this small triangle 20.3 minus the area of this large triangle, which is 37.2. So let's calculate this. 62.8 minus 20.3 minus 37.2. So this is 5.3 centimeter square. So this is not the same as this area in the previous part. So Gavin is wrong. Gavin is wrong because the area in area of shaded region in B2 is not equal to area of shaded region in this part, which is C. So that's how you will solve this question. So this is the end of paper 2, variant 2 for May-June 2017.